shall we get started? So just in case you don't know what room you're in, this is going to be Avoid Deep Herding Deployments Beyond Git. Now, here's one thing. This presentation is already online, so if you're going to wonder where are the links, you don't need to worry about it. If you're a note taker, don't worry about getting each individual hyperlink from me. It's already here at socketwench.github.io/avoid deep herding. Yes, it's case sensitive, so watch out for those D's and H's. All right, I'll give everyone a minute to write that down because I could tell at least a few people are. Okay, so the second question you might have is, who is this weird person in front of you, and do they really get this excited when they have a boarding pass for a business trip? The answer is, I'm Tess Flynn, otherwise known as Socket Wench. That's Wench, not Wrench. I am module maintainer for Flag Friend, and for Examples. And I am a DevOps engineer at 10.7. 10.7 is a full-service web firm based right here in Minneapolis, although now we are a fully distributed company, so we can be everywhere. We could be right behind you right now, as a matter of fact. We do Drupal, design, UX, hosting. Give us a nice hi to the wonderful humans at 10.7.com. So let's talk about deploying Drupal. Let's get into the DeLorean, let's get into the TARDIS, let's get into our time machine. Let's set the way back meter all the way back to the beginning of Drupal history. Does anybody remember FTP? FTP had a lot of problems. It was insecure. All of the passwords were sent over the wire in plain text, so anyone could intercept them. But it was worse than that. There were permissions and modes you have to worry about. So you might say, okay, I'm ready to go and deploy my new site, so I'm going to go and I'm going to open up FileZilla. I'm going to hit the upload button. It's like, okay, that's going to take 25 minutes. I'm going to go and get some coffee. So you go and get some coffee, and when you get some coffee, you come all the way back to FileZilla, and then after that, you're like, okay, everything's done. That took a lot less time than I thought. And then 15 minutes later, you discover that half of your stuff didn't upload correctly because you have to go all the way up in the back scroll to figure out that that happened. And worse than that, you forgot to tell it to check the mode, so everything transferred to text mode, so all your images are all garbled, and it's a frickin' mess. So FTP had a lot of problems. And the worst thing was, it was the only option available. When we were working with shared hosting, they usually only gave you FTP. They didn't want to give you anything else. And then Git came along. And it was like the heavens opened and the angels sung and everything was wonderful. Now all I have to do is SSH into my server. I just change the directory where I host my file. I do a git pull, and that's it. I'm done. Just pull and done, and everything's wonderful. Kind of. So even after you do that git pull, there was always a few things that you had to do. Okay, so you might have to do an update database. So you had to go to your site /update.php, and you had to go run through that and hope that it doesn't die on you, and everything's wonderful after that. And then you might want to do a cache clear, because even if you don't have database updates, you want to make sure that Drupal has everything all nicely updated and things. And you could do both of these through the web UI. It wasn't recommended, but you could do it. And if things stayed that way, it would have been fine. We would have been okay if it was just those two steps, but it didn't stay that way. So now you SSH into your server, you change to the site where your Git directory, where your site is hosted, you do a git pull. Then for Drupal 8, you're going to have to do a composer update. Then you have to do your configuration management import, so you do a drush-chim-y. Then you're going to have to do all your Sass and your less precompiled CSS stuff. So you have to do a compass compile, blah, 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 blah. And then after that, you have to do an updb, and then you have to do a cache rebuild. And it's just so much stuff. You're just going to have to write all this stuff down, and you don't want to write stuff down. You're a developer. You want to get stuff done and be lazy. You don't want to have to write stuff down. But it didn't stop there. The pain kept going after that, because then we had really complex tasks that involved grunt and gulp task runners in order to do all this other stuff. We might have third-party integrations where we have to get some kind of a key file to make Amazon happy and put that into a module somewhere. Or you might be running PHP 7 and you have to use opcache and you have to use, or you're using HPC or something like that. And now you have to worry about clearing that so that everything gets picked up. You might be running behind a reverse cache and proxying web server, and you have a varnish band that you have to do in order to make sure everything's working. And then that's when everything goes well. What happens when things don't go well? What happens if your git pull fails, or maybe your styles don't show up correctly, or you get uncaught exceptions all over the place and you don't know what's going on? And then it still doesn't happen. I'm going to get wrong, because what happens then? You might have missed a deployment step. You might have forgot to gitignore stuff. In desperation, you might have actually did chmod-r777, all the things, and then after that, you might need to roll back, and it's just a bunch of deep hurting. Anyone doesn't know what the reference is to this? This is from a Mystery Science Theater 3000 episode called Invasion of Hercules versus the Moon Men, I believe, and it's on Netflix and YouTube. So all of this has taught us one thing: human beings are fallible. Even if we write the best docs in the universe, it does not remove human hands from our deployment process. We might have had a typo, we might have missed a step, and that can kill a deploy dead. And the other thing is, Git alone isn't enough. It wasn't enough before, and it's still not enough today. Because Git is a code history tool. It is not a deployment tool. We are using it for something that it's not meant to do. So we're all Unixy admins here. We're all DevOps types. So what we're going to do, we're going to make a script, because scripts fix everything. Scripts make the world go around. Then I just have to write the script. I don't have to write any docs at all. I just run the script and I'm done. Well, this solves some of your problems. I mean, you didn't just run the script and you're done, right? Well, if you don't configure your script properly, it might skip steps. And it's like, okay, that gets a little complicated. Well, it reduces operator errors, though, right? It at least does that, because it runs all the steps the same each time. Well, I mean, it might have something that you do that sets a bit of state, and then if you don't have your script checked for that state, now your script might fail and it gets complicated. Okay. Well, scripts are also just generally kind of painful because they're full of really weird, obscure Unixism. Who in this room knows what set-x means? Anyone? We've got one person here. That's the only person, two people, who know what that is. I had to look it up 5 times now in order to figure out what the heck it means, and I have already forgotten. But it's worse than that, because scripts are full of really odd programming conventions. Because in Bash, we don't need them fancy curly brackets. We'll just write if backwards, and else backwards, and case backwards. Then we have to worry about repeatability after that. So you need to check the state first. What if your script makes a directory, calls make directory? And if you don't check if that directory doesn't exist first, the second time you run your script, it will fail. And now you have to litter your script with ifs and else's. And you're starting to go, geez, there's just so much stuff. And this is just no better. This is just no better. Because the problem is that scripts are like tribbles. They start small, but they become a really big problem. And the problem is the complexity that involves with doing a deployment script approaches application code. And that's the problem. They're code, not configuration. So let's talk about config management. There's a lot of different tools out there that you can use for configuration management, but the one I happen to like is called Ansible. Ansible is built by Red Hat. It's called a radically simple IT automation. It is full open source on GitHub. You can download it today. And that's a really good marketing tagline, but what the heck does that mean anyways? So Ansible takes 3 different inputs. It takes something called a playbook, which are the configurations that we want to deploy. It takes a series of targets that we're going to deploy those configurations to, called an inventory. And then it takes some variables which allow you to configure this process. It takes all of these inputs and runs them through the Ansible executable. And what Ansible does is it's going to package those all up, and then it's going to send them over SSH to a remote system. And how it does that is it compiles these inputs into Python scripts on the fly and then executes them on the remote system. Now, they don't actually do the things themselves. What happens is that the Python scripts actually invoke other operating system utilities which are already on the server. This could be file utilities, database clients like MySQL, and also other things like Drush. And this is what Ansible does. This is how it actually works underneath the covers. Ansible also has a lot less dependencies than a lot of other configuration management systems. It only uses Python 2, which means that it works on most shared hosting providers because Python 2 has been around for a long time, and it's part of most Unix environments base installation software. So how do you install Ansible? On most servers, most Debian-based servers, you're going to do an apt-get install Ansible. On Mac OS, you can use homebrew. You can do brew install Ansible. But you could also use the default Python package manager pip to install it, and this will actually download the most recent version directly from the Ansible project itself. And that's the recommended way to do that. Also, you'll probably want to install a number of libraries which will actually work with Ansible. And one of those for us is going to be the MySQL library. The MySQL Python library allows Ansible to talk to databases. So we'll need that because we're doing websites and they're all database backed. Ansible is also agentless. You don't have to install some piece of software on the system that you're managing that has to have some weird port open like 1421 or whatever. Instead, it just works over basic SSH and public keys. So you just set it up like you would to log in over regular SSH, and then you're done. There's nothing else you have to install. If you don't know how to set up public keys, there's this wonderful tutorial on Linode Docs. That's a link, so if you have the presentation open, you can click it, which will tell you all about how to set up public keys. Ansible is also serverless. There's no central puppet master server that you have to install and maintain. There's no fancy GUI. Whatever system runs the Ansible executable is designated as the controller. So that could be an integration server within your data center. It could be the system that you're deploying configurations to. It could be your laptop. It doesn't really matter. So Ansible uses, one of its inputs is an inventory. It's going to be a list of all of the different targets that it's going to manage. And really, it's just a text file with a list of IPs or host names, whatever is resolvable from the controller system. There is one global inventory file for Ansible at etsy/ansible/hosts. And that's going to list all of the hosts that you can have in your data center, but we'll get to how you can extend that later. So you might wonder, how complicated is this? I'm so used to like JSON and XML and a whole bunch of stuff. How complicated is this really? Well, let's take a look at what an inventory looks like. You ready? That's it. Really, it really is just a list of IP addresses. That is an inventory file. That's all you have to do. Now, you can organize this a little bit more. You can actually use something called groups, which uses the square bracket syntax. So let's say you have a cluster of different servers that are managing your web server. You can put them all under one group name. As you can see, we have one here called live. But you can also do other things. You can pass variables to these particular environments. So here we have one that refers to the same system that Ansible is running on, localhost, and we actually tell Ansible using a special variable called Ansible_connection local to use local mode. In other words, don't connect over SSH, just operate locally. So that's a lot of stuff that we can do with just a simple text file. Ansible is also really easy to read. All the code is in YAML playbooks. If you've done Drupal 8 before, you know YAML. You already know how to write a playbook. Congratulations, you're all DevOps engineers now. Also, these playbooks are read from the top to the bottom. There's no weird dependency graph or server model that you need to learn that gets really complicated to manage like it is with Puppet or Chef. It just executes from the top to the bottom until it runs into a problem. That's it. Let's look at a playbook right now. So we start with the 3 dashes, which say that it's a YAML file. And then afterwards, we're going to specify what hosts that this playbook is going to target. So we'll tell it all, just target everything in our global inventory. We can define a number of different variables in the variables section. So we have a variable here that's called heyLook, which just has a value in it called a variable. And then afterwards, we have one or more tasks. Each task is going to start with a name. And this is actually, this name field is for our purposes. It actually is a human-readable name for our benefit, not for the machine's benefit. After that, you'll see this line that looks a little weird called stuff doer. That's called a module name, and it tells Ansible what you want to do. Each module can actually take a number of parameters, so we can have these listed out afterwards. So we have the name of the parameter and a colon, and then the value. And you'll notice that we can actually refer to the variables that we defined earlier with a twig-like syntax. So that actually lets us pass those variables into our playbook. All right, that's the basics. Ansible also has all the batteries included. You don't have to go and find those modules out on the internet and download them and put them in your system and compile them. They're all included when you install Ansible, the entire library. And it's not that big of a library either, because all of those files are actually about 70 megabytes. So that one install accounts for all of the configurations for every bit of functionality that Ansible has. You can find out more about what these modules are and get a total list of them at docs.ansible.com. All right, so let's take our git deploy and let's turn it into an Ansible playbook. So we're going to start with a hosts all. We're going to define a variable that's going to be where our git directory is, and then we're going to do a git clone. In order to do the git clone, we're going to use the git module. We specify the repository URL. Then we're going to specify where that's going to be. We use our variable so that we don't have to figure it out. We don't have to replace it multiple places in our file later. And then we're going to tell it, if we haven't cloned that yet, please clone it. If we did clone it, please update it. And then go ahead and grab this particular branch name. Notice what we don't have to specify here. We don't have to have an if the directory doesn't exist. We don't have to do an else if we haven't cloned it yet. We don't have to do an else if in order to do a git pull instead of git clone. This is one of the expressive powers of Ansible. It does all of that stuff in the module for you instead of having to have you write it all out. It's like the dry principle. Do not repeat yourself. Someone already did the work for you. Just leverage it. All right. So we have a really basic playbook that does a git clone. Let's run it. How we do that is we use the Ansible-playbook command, and then we just specify the path to the playbook. All right. That's great. We're all done. What is it, Mini-Me? Okay, so I mentioned about that global inventory file. What if we don't want to target everything in the global inventory? Because we'll notice we didn't specify at all. So how do we narrow our targets so that we only target groups of systems? Well, we could go into the playbook and we could update the host setting to target specific group names or specific host names. But that's not very versatile. It's kind of a mess. You have to do it each time. It's like, I don't want to do that. That's a lot of work. The better way to do this is to actually use a specific inventory file. You can actually specify an alternative inventory file by passing it -i and then the path to the inventory file itself. This overrides the global inventory, so you can specify just the hosts that you need. So how does this look when you put it all in your Git repository? So we have our project root. Inside of our project root, we're going to have a directory for Ansible, all of our Ansible stuff. Under that, we're going to have an inventories directory, which is going to contain all of our custom inventories for this project, this client. We have two different environments here. We have one for the live environment and one for the stage environment, and that contains all the servers that are involved with those environments. And then we also have in the root of our Ansible directory our playbooks. And these are environment-specific playbooks. So now if we need to deploy just the live environment, we do Ansible-playbook, we specify -i to the live inventory, and then give it the path to live.yaml, our environment-specific playbook. And that does all the deploys for us, and it's environment-specific. So this way we have all of that taken care of. We don't need to worry about that. All right. But there's still a problem. We're still just essentially using git deploy. It doesn't fix any of the problems that caused all of that deep hurting earlier. We don't have all of this other gitignore stuff and chmodding all of the things. Ansible can do all the post-pull stuff for us, but we still haven't gotten away from Git's problems. The problem is that when I started thinking about this, the problem is that we're using the repository directory and the directory that the web server looks like are the same. And that's actually the problem. We don't want to do that. That's actually what's causing all of our hurt. Because the thing with git deploy is that it's a lot like hook menu. Who remembers hook menu? Lots of people. And now in Drupal 8, it's like 4 or 5 different YAML files because we were making hook menu do tons and tons of stuff. Git deploy is like hook menu. We're taking one golden hammer and we're making it do all of this stuff that it's not really good at doing. Git should do one thing well, which is code history, not deployment. We don't want Git to do several things okay. So when we actually had this problem at 10.7, we needed to replace git deploy. We came up with this strategy. So first we have our Git repository directory, and we have a separate directory that the web server is looking at. When we start our deploy, what's going to happen is we're going to do a git pull on our Git repo directory on the server, and then we're going to copy the subdirectory in our repository that contains the Drupal code over to a temporary directory called the build directory. And we're going to use a Unix utility called rsync to do that. Then once we have that build directory, we're going to do everything that we can do before touching the database. So we're going to run our Compass compile, we're going to run our gulp and grunt tasks, we're going to deploy any of those third-party files that we have to set up, all of those artifacts that we need to build. Once we have all of that ready, then we're going to rename the web directory to web directory _old. Now at this point, the site is offline. So during our build, this is when this key moment happens, because our old site files are no longer being served. Fortunately, we don't need to wait very long because we just rename the build directory over to the web directory. And then afterwards, we do everything that we have to do to touch the database. So we do our config import, our cache clear, our database update, and all of that other stuff that affects the database. Once we have all of that done, we're good. That's it. The site's back online. There's a number of different things that are wonderful about this approach. One, there's no more gitignore hell. And the reason why is because the Git directory only mirrors the repository. It does what Git is good at for distributing code. We don't have to run git clean-df anymore on each deploy because the Git directory is always clean. We never build anything in it. Also, a lot of the stuff is ready before the site goes live because we create all of those artifacts that don't touch the database before we switch over to it. That saves a lot of time for us. This includes all those generated assets, compiled Sass, all of that other stuff. Also, there's zero, quote-unquote, downtime. The reason why is because we're using a directory move and not a copy. On Unix systems, when you move directories on the same disk, it's very, very fast. Even if the directory itself is very, very large. And that actually is great because that means that we can do it very quickly without having to worry about it too much. Also, we do it as late as possible in the deployment process. That way, if anything fails, if we have some kind of CSS error, we couldn't build a third-party file, or something like that that happened before we moved the directories, our site never went down. It's still up, and even if our build is broken. All right, so let's put this new deployment strategy into Ansible. So first we're going to assure that our build directory exists. To do that, we're going to use the file module. We specify where the build path is, somewhere on the server. We say we want a directory there. We want it to have this Unix permission mode and belong to this group. Then after that, we're going to copy over our Drupal files from our Git directory over to our build directory. And how we do that is we're going to use the synchronize module. And the synchronize module is basically just rsync. So we specify the source directory and the destination directory. If we've had a previous build failure, we also specify delete yes. And all that does is just deletes any lingering files from the last build. It's important to know that you don't want to forget the trailing slash at the end of source, because otherwise it's going to copy the directory itself, and then you'll have docroot/docroot, and it will not be fun. All right, so let's do the deploy part. We'll move the directories. To do that, we're not going to use a special module so much as just the shell module. The shell module lets you run any shell command on the target system. So we're going to just use the Unix move command. We're going to move the web directory to web directory _old. And then we can actually have the shell module check our work for us to make sure this command worked as we expected. So we tell it, after this process is done, this directory, web directory _old, should exist. And the other directory, the old web directory, should no longer exist. Now that we've got rid of the old version of the site, we would do the new version of the site. We rename the build directory to the web directory, and we check our work. Second verse, same as the first. All right, so everything's awesome. We have our site all up. We have Ansible doing our post-pull tasks, and what is it, Many-Me? Oh, the file directory. I forgot about the file directory. So the problem with this is that our file directory was in our web directory. But now we've moved the web directory to web directory _old. Does that mean that we have to move the directory back each time? That seems kind of risky, isn't it, for all those files? They're only really stored there. We don't want to keep a backup of those anywhere. So, well, what do we want to do with that? Well, really, the solution is to never move the file directory. Here's how we do it. So we have our web directory. We have our public HTML directory that the web server is looking at. We have sites in default, but where you think the file directory is actually outside of the web root. In another parallel directory that's going to be only for the files. And how we do that is we actually use something called a symlink. So the symlink is going to link to the files directory where Drupal expects it to. Apache or Nginx is going to go, oh, I'm just going to look in that directory now. Everything's cool. Don't worry about it. The advantage of this process is the file directory stays put. It is sarcosanked. We never touch it in our deployment processes. So we always are certain that it's going to be fine no matter what happens. But furthermore, this files symlink is now an artifact. It's something that we build as part of our build process that happens before the site goes live. So we don't need to worry about that either. So how do we do that? We're going to use our handy-dandy file module again. We're going to specify where the files directory is in source, where we want to put that symlink under the destination parameter. We're going to tell it, yes, please make a symlink with this mode and this group. And we do that before we do any of the rest of our build steps. All right, now we can do those post-go-live tasks, like config sync import, a database update, and a cache rebuild. So we use the same thing that we did before. We use the shell command, and we just run them all through Drush, like we would normally. So we have Drush configuration import -yes, updb, and crall. Same commands that you know as before, but we also have a different parameter here called chdirectory, which tells the shell module change to this directory before running the command. So now we don't have to even keep track of where that directory is. We just use a variable, and we're done. So what happens if we need to roll back after we do the updb? All of this stuff is great until we have to touch the database, because we still only have one database. How do we fix that? Well, what we really want to do is we want to create a restore point every time we do a build. That's usually pretty labor intensive if you have to do it manually, but what happens if you can automate that entire process? So first of all, we want to make sure that we keep the last site build. We've already done that because we have web_old. If we're working with Drupal 8, we want to archive our configuration management directory, our sync directory. And we also want to create a database dump so that we always have a restore point if a build goes pairs. So what happens is we're going to first use another module called setFact to create a timestamp variable. SetFact lets us create Ansible variables on the fly at runtime. So we're going to ask Ansible, run the pipe command, run the date-i command to get the current date in ISO format, and then store it in a variable called timestamp. So now that we have that, we can use that to create a new archive of our sync directory. So we use the archive module. We specify where the sync directory is. And we're going to say put it in our backup directory /sync/ whatever the timestamp is, and then a file extension. We don't need to specify what the file extension, we don't need to specify what compression method to use, because the archive module is smart enough to look at the file extension and go, oh, you want just a char gzip, that's fine, or whatever format that you want. Now we want to back up the database. To do that, we're going to use the MySQL _DB module. We're going to say we want a dump, state dump. We want to say, okay, use this database name, store the dump in this directory. Again, we don't need to worry about compressing it in a second step. The MySQL DB module is smart enough to look at that file extension for us and do the compression for us. And then we specify the host name, the port, the user, and the password. Cool. But there's still a problem. The problem is, I still have to make this playbook run myself. And I don't want to do that. I don't want to actually have to have someone to tell me, go ahead and run this playbook and do this deploy. I want the server to do it instead. Because I just want to be lazy. Tell me if you've heard this story before. You're working as a DevOps engineer in your small organization. One of your developers goes to you and says, hey, can you deploy this code out to stage for me? And because you're a DevOpsy person, you have a self-loathing nature, and then you're eager to please other people, you say, sure, give me a few minutes, I'll take care of it. 2 hours later, your developer comes back and asks you, what the heck is going on? Why am I not seeing any changes? And because they're a developer and they also have a self-loathing nature, they're wondering, what did I do wrong to make my code not work? And the real problem is you forgot to deploy all that stuff because you got distracted and then you went and had lunch. I call this Slack to deploy. It is a terrible, terrible way to run organizations, because it not only bottlenecks your developers when they're testing and releasing code, it also makes the ops person's life a living hell. It makes their life a never-ending firefight, because in addition to making sure that systems are always running, fixing problems when there are outages, there's always someone who needs something to be deployed, and your hair is always on fire, and you might as well say that it's a hairstyle and not a job description. What we need is something called continuous integration, or CI. It's a really, really fancy word for actually a pretty simple concept. So commit smaller pieces of code more often, and then deploy those pieces of code out to servers as often as possible. And sometimes this can be multiple times a day. The thing is, with CI, it only works if you have automation to back it up, because we don't want to have our ops people always on fire. To do this, we have something called a CI server. It monitors your Git repository for events, and then it performs actions in response to those events. So, how does this look? We have our developer. They're going to push their code up to a Git repository, and the CI server is going to receive an event of that thing happening on the Git repository. The CI server is going to look in a database or a file somewhere for a series of rules. And it finds those rules and finds out that, oh, I need to SSH or SFTP over to a server, and I need to deploy some code over there. Awesome, I'll go and do that for you. There's a lot of CI servers out there. There's Circle CI, there's Jenkins, there's a whole bunch of stuff. But the one I like is called GitLab CI. It's integrated with GitLab Community Edition. It is free and open source, and you can get it today. How do you get GitLab? There's a lot of different ways you can do that. You can use GitLab.com's free tier. It includes CI out of the box for you for free. If you want, you can download GitLab yourself and self-host it. This requires a bit of Unix skills. It's a bit complicated. Or if you're a lazy person like, oh, you'll probably want to just use Docker. What does this look like? This is actually the Docker Compose file I use for my ridiculously named integration server. Yes, I actually bought that domain name. And all this has is it has the GitLab image, and then it has the GitLab runner. There's a known issue, which is why the GitLab runner is a specific version, because there's a bit of a small problem with how it works in Docker right now. But this version works. OK. So now we have GitLab and GitLab CI installed. Now we need to figure out what we're going to do next. How do we get those two to work with our web server? Well, we know that GitLab and GitLab CI already talk to each other because they're sister products, so they know what happens when there are Git events. GitLab CI has the connection details somehow. We'll get to that. And because of the way that GitLab is implemented, it actually keeps the deployment script inside of the repository. So we have all of that information. What those CI rules look like in GitLab CI is a file called .gitlabci.yaml. And it basically maps a repository event to a series of steps to execute. So here's what this looks like. This is an actual production file that we use at 10.7 for our deployments. And there's a lot of stuff in it, but the important part is there's this job area up here which specifies what tasks to run. It has a script which tells us the thing that we're going to run. And then it also specifies this only parameter, which is the branch name. So this one's going to do whenever we have a push to the master branch, it's going to run an Ansible playbook with a custom inventory file in our environment-specific playbook. That's it. Everything is right there to do a deploy for us. If you have another environment, you just duplicate it off. So now we have our deploy task. We're going to have another script which specifies a different inventory file and a different environment file. And then we're going to say map that to the develop branch. Cool. That's it. That's our entire CI rules. Where do we put this file when we get it? So we have our project root. We have our doc root directory with our Drupal stuff in it. We have our Ansible directory with our environment-specific playbooks. And we put the .gitlabci.yaml file at the root of our repository. Once we have that, GitLab knows that this is a CI-enabled repository and will automatically include it in event monitoring. Now this tells GitLab two things. It tells us what to do in our environment-specific playbooks and when to do it in our GitLab CI.yaml. But what about where? Where's the connection information? In order to make that work, we need another thing called a runner. A runner is basically just a process which executes the builds. And it's typically created for a specific project. And you can have any number of them on a server. How it works, you have GitLab runner. GitLab runner takes a number of different inputs. It takes a series of tags which maps a task within our GitLab CI.yaml to the runner. It takes the SSH login, which is created with the runner. And then it takes the rest of the CI.yaml file. It connects over SSH to our target system. And it starts a new shell session. And from that shell session, we can do a number of different things. GitLab, by default, will clone the repository for you with the specific commit that you actually just pushed instead of whatever head is. So you always get the right code when you're doing a deploy. Then we can run Ansible and other utilities as necessary. Cool. How do you make a runner? When you're on your system where GitLab runner is on, you just use the GitLab runner command, and you can specify the SSH connection information there. So that takes care of making the runner, and that's where our connection information comes from. Now there's a few different ways that you can actually set this up, because we have both Ansible and GitLab CI. One way that we tend to do it is that we have the runner connect to the web server, and then Ansible just runs locally. This is great on our own hosted platforms that we maintain at 10.7 because we maintain Ansible on those platforms. But it doesn't really work for shared hosts very well. The other way that we want to do that is we want to put the CI server, the runner to connect to some integration server, which we do manage, that has Ansible installed. And then Ansible connects to the shared hosting provider remotely. That way, we never have to worry about having Ansible installed on the shared host. So this handles both cases for us. So we never have to worry about if the client is on our hardware or on their own hardware. It just works. But we forgot something, didn't we? So we have our new CI-powered deployment method that's all Ansible-powered, all in playbooks, everything's great. We just have to do a git push, and CI does all the rest of the stuff for us, and we're good. So we hit the deployment button, and everything's fine. We wait to check our new site, and it doesn't go very well. And that's because we forgot one thing. We forgot that we don't want to put the database login in our repository. We didn't specify that anywhere. And we don't really want to do that because the old axiom still holds true. We never want to put the database login in our repository. There are other stuff we might want to keep out. Like we might want to keep out API keys or cloud identity keys like an Amazon IAM account. Hash salts maybe have a security argument for not keeping those inside of a repository. That's debatable. The problem is that even though we built all this fancy CI already, we still have to SSH in and add the database credentials each time. That sucks. That's no better than what we had before. I still want to be lazy, damn it. So CI should deploy all the credentials too. So how do we do that? We use something called GitLab secure variables. They're unique per repository, and they're stored encrypted on the GitLab server. And they're really easy to define and edit. There's a nice web UI that takes care of it for you. So how do we do that? We define our secure variables inside the GitLab UI for our project. And then when GitLab CI deploys our project, it exposes those secure variables as environment variables. And then we map those to Ansible variables in our playbook. So it looks a bit like this. This is our regular variables that we set up earlier. Here's where we keep our database connection information. We do a lookup, which grabs an environment variable with these particular names. And if you're a security-conscious person, you're going, whoa, don't do that. You're putting environment variable, secure stuff in an environment variable? That's a bad idea. Well, it is, but the thing with GitLab CI environment variables is that they're only set during the build, and only for that build's shell session. So you literally have to find the shell session that GitLab runner is invoking, break into it, and grab the environment variables from it. And if someone already could do that on your system, you have bigger problems. And because all these variables are not persistent, they only exist for that build session, the attack surface is a lot smaller. So it works very well in practice. So that takes care of the build, but we still have the problem with settings.php. We can get the variables into Ansible, but how do we get Drupal to get the variables? So we don't want to put it in the repo, so we don't want to have this sitting in our repo. That's a really bad idea. So how do we do that? Can we get CI to write them during the build? Turns out, yes, it can. There's a thing called Ansible templates, and it replaces placeholders inside of files with Ansible variables. And it uses a Twig-like syntax. So if you knew even a little bit of Twig, you already know how to use an Ansible template. To use Ansible templates in a playbook, use the template module. You're going to specify the source file that contains the template and the destination file. They can be the same file. It doesn't have to be two different ones. And other things, you can set the file mode or the group optionally if you need to. All right. Inside of that, our template, we actually replace all of that secure information with just the variable name. So this is what's in our repository now. Ansible templates also support Twig-like filters, so we have a default here. So we have a default host of 127.0.0.1 and a default port for MySQL of 3306. Nothing fancy. All right, That's great. But the problem now is we have yet another problem. When we do a deploy for multiple environments, we're going to have two different settings files. Each one of these is going to have our different database credentials because we've templated them off. But what if we have config differences between environments? What if one's using Varnish and one isn't? One has, stage file proxy enabled and the other doesn't. Where do we store that? Well, a lot of Drupal people are going to be really familiar with the idea of a settings.local.php. What we do is we extend that same idea to settings.environment.php. So now each one of these files now has an environment-specific settings file, which is get backed. This way that we have all of our settings get backed, and also everything is still templated off, so it's not stored in the repository. And that takes care of everything. So now we have all of that taken care of. So how do we actually get settings.php to pay attention to this? We need to first of all, we are breaking it up into per environment files, but we also need to conditionally include those per environment files. If you've ever used settings.local.php, you might be familiar with adding this line to settings.php. Same idea here. So you're going to add some kind of criteria. In this case, we're just going to use some directory name that's unique per environment. We can also use an environment variable or other methods to identify what environment we're in. And then we conditionally include the correct environment file. And that takes care of it for us. So now every site knows exactly what environment's on and what settings to use, and the database credentials are all templated. We need to update our template module, our template step in our playbook. So we're actually going to update that with a little bit of a change. Before it was just settings.php. Now we have an environment name variable, which is going to change that name for us. So we have settings.livephp or settings.stage.php. Cool. That takes care of that for us too. But what if you have multiple projects? How do you take care of that? Because if you're working with your projects for a while, even after you have all this nifty stuff, which seems like CI heaven, you now have multiple sites which you deploy your CI out to and all your Ansible stuff out to. And you'll start realizing that this stuff looks pretty similar across the different sites. Wouldn't it be nice if we could actually make them all reusable and extendable so that we don't have to copy and paste these environment-specific files and then modify them each time? Turns out Ansible thought of that too. There's a thing called Ansible roles. These are reusable parameterized configuration sets. They're basically packaged up playbooks that include variable defaults. I'm not going to talk about how those are set up because that's a bit of a topic in of itself. So you can look at the documentation on Ansible.com for roles. The hyperlink is right there. All right, so we've taken all of our code, we made it all reusable with roles. We put those roles inside of our Ansible directory. But we still haven't solved the problem yet, because now we're copying and pasting the roles, which is okay if we never touch the role code, but what happens if there's a bug in our role code? Now we have to go to each individual repository, and you have to paste the new version in, commit it, and rerun the build, and it's a mess, and it takes too long. We don't want to do that. What we want is we want to put all of our roles in the same place and then have CI deploy them out too. There's another thing called Ansible Galaxy. Ansible Galaxy is distribution for Ansible roles. It is free. You can find it at galaxy.ansible.com. To get roles from Galaxy, you're going to use the ansible-galaxy install command, and it takes one or more org.role names. Now, if all of this seems complicated and it's like, oh man, that's a lot of stuff that you're throwing at me, Tess, what are you going to do now? Well, it turns out all of our deployment scripts we've already made free and open source for you to use today. It's all on Ansible Galaxy, and you can find it at 10.7.drupal-backup or 10.7.drupal-deploy. And you can find the source code on GitHub. Now, what if we have, since we have these two roles, our deployment role and our backup role, we don't want to specify the Ansible Galaxy command twice. It'd be better if we put that in our repository too, right? So we have a requirements.yaml file, which is just a list of roles to install. and that can be from either Ansible Galaxy or our own private Git repo, so that we never have to involve Galaxy at all. Here's what the requirements.yaml file looks like. It's just the role names. That's it. So we update our GitLab CI.yaml file. So now we have another command, our Ansible Galaxy install command, and a whole bunch of stuff. But the important part is that it references our requirements.yaml. And then we continue the rest of the build like we did before with our environment-specific playbook. So let's break down that file, that command. Do a good install from Ansible Galaxy. Download the file each time. The reason why we want the roles to download each individual time is if we update them, the build, every time we rebuild a new site, it automatically pulls the new version of that role from Ansible Galaxy and installs it for us. So it's always up to date. We specify our requirements file, and just because sometimes GitHub does go down, we want to do ignore errors. If the build was successful once and Ansible Galaxy ran at least once, you have a locally cached version of the roles on your server, and it will just fall back to them gracefully. So that takes care of absolutely everything. Now your ops person is happy, their hair is no longer on fire, and you can actually have them do other things. You can have them help out with the back end or do other projects around. You can have them focus on making your CI better instead of constantly fighting deploys. There are a few more things you might want to try. You might want to use something called group variables for cleaner playbooks that remove the variable statement from your playbooks and puts it in a separate file. It's really handy. You might want to have Ansible configure cron for you so that Drupal cron is always set up every time and those settings are backed in your Git repository. Or you might want to set up an open source backup solution that I actually wrote and that we use for 10.7 called Tractor Beam. I have stickers up front if anyone wants it. It is an alternative to Node Squirrel that actually does multi-tier offsite backups to Amazon S3, and it is completely open source. Also, there's some things to read. If you feel really intrepid, you can actually read the continuous integration book. It is meant to be for college courses instead. It is really thick. It is really dry. It is probably not really worth it to read, in my honesty, but it provides a lot of valuable insights if you want to get your head around the entire concept of continuous integration. You might want to read Jeff Gerling's excellent book on Ansible for DevOps, which you can get in ebook form today. And there's always docs.ansible.com. And before I finish, I want to give a few special thanks to Twin Cities Drupal for having me here today to present 10.7, for also supporting me, and also my wonderful backers on Patreon, which support my writing efforts, including my migration series, which is currently ongoing. Don't forget that there's going to be sprints tomorrow at ICF Olson. It's going to be at 9:30 to 5 o'clock. The address is on page 13 in your name tag booklet-y things. And there's going to be help from mentors all day. I'm going to try to be there tomorrow to work on flag or example module or something. And I want to say a big thank you for all of you being here today. I know it's a Saturday afternoon and that you're all rather sleepy right now. You can find this presentation on github.io. Question?
I'm a little confused with the new thing about installing Drupal with Composer. Composer builds a directory system and has vendor outside of the directory. And the gitignore says, keep that vendor thing out of there.
So we
haven't... Push it up, it doesn't show up, and so how do you get it on the other side?
See, the thing is, so the question was about installing Drupal with Composer, and we actually haven't switched to that workflow at 10.7 yet because we have a lot of custom sites, and right now it's been easier for us to still use a more Drupal 7 modality where we keep the entire site code in the repository. It should be conceivable that we could modify our deployment method to make that work, but I haven't done that yet. So this still uses a slightly simpler one, doesn't go all in on Composer. I think you were next.
We do that, and when we're generating the artifacts, we just run Composer on the server, and it works pretty well. During the artifact generation, when you have the temporary folder, just to respond to that, but I also had a separate clarification question.
Okay, before you get to that, let me repeat it for the recording. So that wasn't so much a question as it was an answer about they just run Composer on the server to do the deploy. And then now you have a question?
Yes. So just to clarify, there were 3 settings files, the settings.local, stage, and live.
Well, there's actually just 2. The settings.local is actually kind of a fallback artifact just in case we want local developers to use that on their system. We actually have mostly switched to a Docker-based workflow, so there's a setting.docker.php now that contains those for local development.
And so I'm just wondering if the stage and live ones do get committed to the Git repos?
That,
Docker do not, right?
So actually the stage, the live, and the Docker settings.php files all do get committed to the repository, which is a little bit of a hard thing to do because you're so used to like, I need to gitignore all these things. But if those are Git backed and templated, it's completely safe to include them. And in fact, it's easier to do that because now that's actually just all backed and all tracked. The thing that we don't include is settings.local.php. That is always a global fallback. It always wins if it exists.
Okay, cool, thank you.
And I think you had a question next?
Yeah, just, can you also use Ansible to do a pull so a developer can basically clone the production site for bug fixing?
Sure. So the question was, can you use Ansible to do a clone to pull the production site? The Drupal backup role that I have actually does have something called fetch in it, which uses I think it's literally called the fetch module. And what it does is it goes out to SSH to whatever the target server is, and then duplicates whatever you want from that server to your local environment. And I actually have used that to grab not only the site files, but also the database and anything else that I need to my local. Question?
My question kind of builds on that. I was curious if you could talk a little bit about what a local development environment looks like, and does each project repository have like a Docker file and a Docker config tracked with it?
So how we do this at 10.7, the question was, do we have this, what do we do for Docker in our organization? So I actually wrote the Docker stuff too for 10.7, and we have something called DocStack. You can go to GitHub, 10.7/DocStack, and that's actually our standard environment that supports 6, 7, and 8. And what we have is we have a .environment file, .env file, which we use to configure the environment, specify the databases to create the database passwords to use locally. And then we have a docker-compose.yaml file, and you add those 2 to the repository. And those are only used for developer stuff, so we don't keep secure information there. It's admin password. It's nothing fancy. I think our regular login for our Docker stuff for the database is like root. it's nothing fancy because it's a local development environment. We obviously don't do that for production or for staging environments which are shared, but for local stuff we don't care.
But you do like to track that, right? So each project repository has a Docker compose.yaml file.
That's correct.
Like a local .env
right.
for local.
So the basic setup that we have if we want to Dockerize any of our projects is that we're going to first add that .env file from the Git repository, from the DocStack Git repository. We customize it if necessary. Then we're going to copy and paste the docker-compose.yaml. And then we modify the settings.php to select the Docker image, select the Docker settings file when necessary. And then lastly, we add a settings.docker.php. And we commit all 4 of those to the repository. So that basically a new developer, all they have to do is, do you have Docker installed? Cool. Okay, clone this repo, go into the repo, hit docker compose up-d, and you're on. You still have to copy and paste database into it, but that's the only other step. And if you've spent more than a few months around Drupal, you know how to do that already. So it makes it really easy to stand up a new project.
Awesome.
Question?
So Ansible offers something called Ansible Vault for secure password management, or anything that is sensitive. How does it compare to using the GitLab variables?
Okay, so I think what you're referring to is Ansible Vault.
Yeah.
Okay, so the question is Ansible Vault versus GitLab secure variables. They're both good options. The problem with Ansible Vault is that it actually still requires you to keep the encrypted environment values in your repository, because you still need to get those out to the server somehow. And one of the CI rules that you really should know is that the Git repository is everything. It stores absolutely everything that represents that project. And that is your sole input to modifying that environment. Everything else has happened with CI. You never are supposed to log into it. So you can use that. And if you don't have GitLab CI, sure, go ahead, use Ansible Vault. That's fine. The encryption is actually, I think, 4028 something bit encryption, so it's really good encryption. So it would take quite a bit of time to crack, and I don't think anyone with a quantum computer is going to try to attack your website with that. So I think you'll be fine. The only manual step you'll have to do with Ansible Vault is you do have to deploy the password in a plain text file somewhere on the server. And you have to do that manually. That can't be in the Git repo because it's a password, and that just ruins the entire purpose. But once it's there, that's a relatively permanent and stable artifact that you just keep there all the time. And as long as it's outside of your Git managed directories and your deploy managed directories, it should be fine. And then I think, I forget exactly how it works. I think you specify the password file parameter when you run the playbook. I think that's how that works. So I left it out of the presentation because it takes like 3 minutes for me to explain it, and I wanted time for questions. So yeah, it's a perfectly valid way of doing it.
Thank you.
Anyone else? I have stickers up front for both Tractor Beam and also example modules. Please don't make me go home with these. Please take them. Thank you, everyone.
Thank you.
Good night, boopies.